we're now going to model the flywheel post. So we're going to start a new standard millimeter IPT, and we're going to do a sketch on the XY plane. And to start with, I'm just going to sketch the rough profile of the post. So you can see, when you hover over the end of a line, you can see there's a grey dot, and that means if you hold the left mouse button down, it actually takes you straight into drawing an arc. So I'm going to carry on and finish that up. I'm going to use the equals constraint, pressing equals on the keyboard to make these two the same. And I know the dimension there is 6mm, this one on the bottom is 64, and you can now see it's starting to take shape. And the other thing I'm going to do is I'm going to make the midpoint here, or the centre point, coincident with the midpoint of this line, and that will become apparent a little bit later. And the other dimension we need to do is to the top. So if you click anywhere on this arc here, it will actually give you the dimension to the centre point, whereas when you're in the dimension tool, if you hover over the top quadrant, you'll see that the symbol changes, and that will actually let you do it to the quadrant, and then you can add this dimension in here, which is 70, and the final dimension is actually the alignment of this the centre point of this arc. Okay, so one thing I do when I'm trying to work out what still needs to be defined in my sketches, that's one of the things I do. I sort of pull geometry around just to see where it goes. So I'm going to add that vertical constraint in from the centre point of this arc to the centre point of that line on the bottom, and we also have to give this the radius dimension in here, which is 17.5. And you can now see our sketch is fully constrained. I'm going to hit E for extrude. It defaults to 10mm, which is good because that's what we need. I'm going to change it to midpoint and hit OK. And now there's 4 holes along the bottom, so I'm going to start by doing those. I'm going to do the 2 outer holes first, so I'm going to use the point tool. Again, make sure you align these using the constraint, so I'm going to horizontally align these with the midpoint of this line. And then we need to put the dimensions on. So this one first. And if you press H for hole tool, it takes you straight into the hole tool. Now we've got some blind holes that are threaded, so we're going to change that to threaded. The thread isn't full depth, so make sure you take that off. We need to give it distance. Like I said, they're blind holes, so it's an isometric M5, and make sure you get the designation correct. It's 0.8, and the thread depth is 10mm, and the blind hole depth is 12.4. And you can see there it's given us a preview, just so you know what it looks like. You can hit OK. And there's also 2 more holes, so I'm going to repeat the process. Align them first, and then add the dimensions. H for hole tool. Now these blind holes, again, they're not threaded, and they're 55mm deep and 2mm diameter. Again, I'm checking on the other view, it shows me the hidden detail, so I know that these are angled at the bottom of the drill point and they're not flat. So now you can see we've got the holes that go in the bottom, and these 2 run all the way up. I'm now going to sketch 2 sort of half moon shapes that are very similar to those on the valve port block. One of the most common mistakes people make is they actually draw the centre point of the circle on the centre point here of the arc, whereas there is a dimension given to you. So I always put in a construction line. Oops. And you can see I actually just missed that, so I'm going to extend that out to the extremity. And there's a dimension in there of 53. Now if I just zoom in just to show you, you can see it's not on the centre point. And it is details as small as that will lose you points that could cost you the competition. So now we've got that, I'm going to draw in my circles. So the first one is radius 5, so we know that one's 10mm diameter, and I've left that on construction, so I'll change that back. And then we've got our outer one, so I'm going to put the circle down. I could put in the diameter of that, which is 22, or the alternative thing you can do is you can put a distance in between like this, and we know it's radius 3, so it's 6mm. So now we've got our 2 outer, our ID and our OD. And now we need to put in our circles. I'm now going to draw in 2 circles, which will give us the two ends. I'm going to make those equals with each other and I give them the dimension of radius 3, so 6mm diameter. I'm also going to vertically align those because we can see that from the drawing, and we do have a dimension between them, which is 11mm, and we know they're equally spaced, so what I'm going to do is add a dimension between here and here, but rather than putting 5.5 I'm going to click this dimension, reference it and say divided by 2, and now the last thing we need to do is make it tangential to the curves we've already drawn. So now you can see we're fully constrained. Obviously we have a lot of excess geometry here, so I'm just going to go and trim. So I've pressed X on the keyboard to open the trim tool, and I'm just going to trim away all the stuff that we don't need. And that's that part done. I'm going to extrude that. It's 2.5mm deep, so change that to cut 2.5. There's also a hole on that face there, and it's very careful which face you choose here. So the drawing is telling you it's 5mm deep, and then if you look at the hidden view you can see that this hole does not break through the other hole. Now if you sketch and do the hole starting on this face at 5mm deep, it will actually break through the hole. So it's very important that you look at all the views to understand exactly what's going on. So I'm going to draw a sketch on here, and I'm going to put the point down, and we've got the dimensions in the X and Y. So we've got this one here is 53, and this one to here is 8, and that hole is 2mm diameter and 5mm deep. Just to show you what I mean, I'm just going to go around the other side. So I'm going to look at this here. If I just change the style here so you can see. You can now see that this hole doesn't break through, whereas if I had done it on that face, the hole actually does break through. So it's very important that you look at the drawing, look at all the views to make sure what you're doing is correct. So I'm just going to go back and carry on. So we've also got another hole that goes through the centre here, and again you make sure you get it on the right area. So just to be sure, I'm going to put a point down, and I'm going to dimension it rather than putting it on one of those, and that's at 53mm, and it's vertically aligned with the midpoint, and this is actually an M5 through all. Again, make sure you get the correct designation. That's not distance, that's through all, and the thread is full depth. Hit OK. So now last thing to do is to mirror these two around the plane which is in the middle, and that's exactly why in the first sketch I actually put the centre of this line, I snapped it to the midpoint. So now we can go into our origin and actually use our YZ plane as our mirror plane. That saves us making another work plane. And the final thing to do is just add the material to this, which in this case is stainless steel. And there you have the completed model. So I just need to save that one, and that one's Flywheel post.